Hello my dear students, how are you? Welcome to our channel Maths for All. In this video, we are going to discuss one more important chapter for JEE mains, that is differential equations. Okay, so in the differential equation, there are a lot of methods to solve differential equations. So let us discuss one by one. So the very first method to solve a differential equation is variables separable method. The name itself tells us separation of variables. Suppose if a differential equation contains two variables, that is x and y. If we can bring all the x variables to dx side and all the y variables to dy side, so then we can integrate by using this variable separable method very easily. If you can bring the all x variables to dx side and all y variables to dy side, provided dx and dy are always in the numerator, then that is called separation of variables. Separation of variables. So let us discuss one important example so that you can understand the method. The first question is like this. Square root of 1 minus x square into dy by dx plus square root of 1 minus y square is equals to 0, 0. If y of 1 by 2 is equals to root 3 by 2, then he is asking the value of y of minus 1 by root 2. He is asking the value of y of minus 1 by root 2. This is the question he is asking. Remember, this is the previous mains question. Previous mains questions only we are going to discuss. We are discussing here. Acha. The solution. So let us check. Can we separate the variables here? See, do one thing. Square root of 1 minus x square into dy by dx is equals to, take this term to that side, that is minus square root of 1 minus y square. So now bring this root of 1 minus y square term to dy side. This is dy by square root of 1 minus x square. Square is a root square root of 1 minus y square. That should be equal to, so take this root of 1 minus x square by dx to that side. Your minus sign is already there. So dx by square root of 1 minus x square. So now all the y terms with dy and all the x terms with dx, provided dy and dx are always in the numerator. Achha. So now variables are separated. So this can be written as dx by square root of 1 minus x square plus dy by square root of 1 minus y square. That should be equal to 0. So after separation of variables, integrating on both sides. Integrating on both sides. So this is integral dx by square root of 1 minus x square plus integral dy by square root of 1 minus y square is equals to 0. So the integration for 1 by root of 1 minus x square is sin inverse x, and the integration for 1 by root of 1 minus y square is sin inverse y. That should be equal to some integration constants. In differential equation, constant of integration plays an important role. So sin inverse x plus sin inverse y is equals to sin inverse c. So this is the solution of the differential equation, but he is giving some conditions. Y of 1 by 2 equals to root 3 by 2. Why is given like that? So to find out the value of c, that means he is asking the particular solution. So this is called general solution. This is called general solution. If you can give some values to per c, so that is called particular solution. C is given y of 1 by 2 is equals to root 3 by 2. This is very important. Is y of 1 by 2. So this is of the form y of x. Remember, y of x, y of x, y of x. So that means here 1 by 2 means x. 1 by 2 means it is a value of x. So y of 1 by 2 is equals to root 3 by 2 means, after getting the solution, after getting the general solution, substitute 1 by 2 in the place of x and root 3 by 2 in the place of y in the general solution. That is the meaning of this one. Y of x is equal to root 3 by 2 means, after getting the general solution, substitute 1 by 2 in the place of x and root 3 by 2 in the place of y, so that you can get the value of c. So just substitute. So put x is equals to 1 by 2 and y is equals to root 3 by 2. So then that is sin inverse 1 by 2. sine inverse 1 by 2 plus sine inverse of root 3 by 2 is equal to C. So sine inverse 1 by 2 is nothing but pi by 6, it is 30 degrees, plus sine inverse root 3 by 2 means pi by 3, it is 60 degrees, that equal to C. So the value of C is equals to pi by 2. The value of C is equals to pi by 2. So now the particular solution is, therefore, sine inverse x plus sine inverse y is equals to pi by 2. Sine inverse x plus sine inverse y is equals to pi by 2. Acha. Okay. So now, you know the important result in inverse trigonometric, sine inverse x plus cos inverse x. Sine inverse x plus cos inverse x is equals to pi by 2. So here y is nothing but square root of 1 minus x square, or you can substitute directly x is equals to minus 1 by root 2, so that you can get y of minus 1 by root 2. He is asking y of minus 1 by root 2. He is asking y of minus 1 by root 2. That means when x is equal to minus 1 by root 2, when x is equals to minus 1 by root 2, what is the value of y? He is asking. The meaning of this one is, when x is equal to minus 1 by root 2, the value of y is what? That is the meaning of this one. So now put x is equal to minus 1 by root 2. Put x is equals to minus 1 by root 2. So if x is equal to minus 1 by root 2, sine inverse of minus 1 by root 2 is minus pi by 4. What is that? Sine inverse of minus 1 by root 2 is minus pi by 4. Now take this minus pi by 4 to that side, plus pi by 4. So sine inverse of y is equals to pi by 2 plus pi by 4. Pi by 2 plus pi by 4, isn't it? Now y is equals to sine of pi by 2 plus pi by 4, it is cos pi by 4. So cos pi by 4 is 1 by root 2. So therefore finally y is equals to 1 by root 2. So when x is equals to minus 1 by root 2, y is equals to 1 by root 2. That means the value of y of minus 1 by root 2 is 1 by root 2. This is the answer for this question. So this is the process to solve a differential equation is given in variables separable method, right? Let us discuss one more question based on variable separable. Clear? The next question is like this. E power y into dy by dx minus 1 is equals to e to the power of x such that y of 0 is equals to 0, then again he is asking the value of y of 1. If y of 0 is equals to 0, he is asking about the value of y of 1. Achha. So this is the given differential equation. Let us see how to solve this differential equation. So dy by dx is equals to, take this e power y to that side, it is e power x by e power y, so that it is e to the power of x minus 1. E to the power of x minus 1. Achha. So this is dy by dx minus 1, sorry, dy by dx minus 1. Okay. So whenever this type of questions are given, so let us take this x minus y as some z. Put x minus y is equals to z. X minus y equals to z. So after taking this x minus y is z, now I want the value of dy by dx. So how do you get dy by dx? By differentiating y with respect to x. So that differentiate entire equation with respect to x. Differentiate with respect to x. So the derivative of x is 1 and the derivative of y with respect to x is dy by dx, and the derivative of z with respect to x is dz by dx. So by taking x minus y value as z, then the value of 1 minus dy by dx is dz by dx. So now the given differential equation becomes, see, this is dy by dx and minus 1, this is 1 minus dy by dx. This is dy by dx minus 1 and this is 1 minus dy by dx. So the value of dy by dx minus 1 is minus dz by dx. Achha. Is equals to e power, the value of x minus y is z. Now observe, in this differential equation only two variables. Those are z and x. Z and x. Now I can separate the variables here. See, I can bring all the z terms to dz side. How? So take this e power z to this side. So it is minus e power minus z. If you bring e power z to this side, it will become e power minus z dz is equals to only dx is there. So take that dx to that side. See, the variables are separated now. Now the variables are separated. Achha. So now bring all the terms to one side. So take this minus term to that side, e power minus z dz plus dx is equals to 0. So now the variables are separated. So now it is ready to integrate. So integrating on both sides. So therefore, integral e power minus z dz plus integral dx, that should be equal to 0. The integration for e power x is e power x. So the integration for e power minus z is e power minus z by minus 1. So the integration for e power minus z is minus e power minus z minus e power minus z plus the integration for dx is x is equals to, don't forget to write the integration constants. It plays a major role. Now, first of all, you have to replace z. What is z? X minus y. It is minus z minus what means y minus x. So minus e to the power of y minus x plus x is equal to c. Achha. So initially he has given that y of 0 is equal to 0, y of 0 is equals to 0. Again I told y of x is equals to 0. That means you have to substitute after getting the solution. You have to substitute 0 in the place of x and 0 in the place of y. So now put x is equals to y is equals to 0. If x is equal to y is equals to 0, see this is e to the power of 0 minus 0, it is e power 0, e power 0 is 1, so it is minus 1 plus x is 0. So the value of c is equal to minus 1. The value of c is equal to minus 1. So just replace c. So e to the power of minus e to the power of my y minus x plus x is equal to minus 1. Achha, now what he is asking, y of 1, y of 1, that means when x is equals to 1, what is the value of y he is asking. Y of 1 means when x is equals to 1, what is the value of y he is asking. So just now substitute, put x is equal to 1. Put x is equal to 1. Achha. If x is equal to 1, then e to the power of minus y minus 1. So x is equal to 1, it is plus 1. Take that side, it is minus 2. It is minus 2. Achha. So therefore, so minus gets cancelled. E to the power of y minus 1 equal to 2. So that y minus 1 equal to log 2. So y minus 1 equal to log 2. So therefore, y is equal to 1 plus log 2. Y equal to 1 plus log 2. So when y of 1 means when x is equals to 1, what is the value of y? So when x is equals to 1, the value of y is equal to 1 plus log 2. This is the answer for this question. Clear? So this type of questions you may ask in the previous mains question list. This is also the previous mains question. Is asking very simple questions. Very simple question. Okay. Next we'll get to second method, homogeneous differential equation. Homogeneous differential equation. See, before going to discuss about homogeneous differential equation, first of all, you should know what is a homogeneous function. Let us see. A function f of x comma y. A function f of x comma y is said to be a homogeneous function. Said to be a homogeneous function if it satisfies the following condition. If f of kx comma ky is equals to k to the power of n into f of x comma y. A function f of x comma y is said to be a homogeneous function of degree n if f of kx comma ky equal to k to the power of n into f of x comma y. Whenever a function f of x comma y satisfies this condition, automatically the function is said to be a homogeneous function of degree n. Suppose for example, a function f of x comma y may be like this. This is x cube plus 3x square y plus 2xy square plus 4x cube plus 4x cube. By observing, you can say whether it is homogeneous or not very easily. So here how many terms are there? 4 terms are there. In first term, how many variables are there? 3 variables, that is x into x into x. This is x cube. In second term, how many variables are there? 3. X square into y. In third term, how many variables are there? X into y square. 3 variables are there. In fourth term, how many variables are there? 3 variables are there. This is 4y cube. So in each and every term, how many variables are there? 3 variables. So therefore, this is a homogeneous function of degree 3. By observing, you can say, suppose if you apply this definition, what will happen? So find out f of kx comma ky. So replace each x with kx and each y with ky. So kx whole cube, it is nothing but k cube x cube plus 3 into this k square x square into ky, k square x square into ky, it is k cube x square y, plus 2 into kx into k square y square. So 2 into it is k cube xy square plus 4 into k cube y cube. So in each and every term, you can take k cube as a common term. So k cube times of x cube plus 3x square y plus 2xy square plus 4y cube. So this is k cube into f of x comma y. It is k cube into f of x comma y. Right. So therefore, it is a homogeneous function of degree 3. It is a homogeneous function of degree 3. So whenever if a function satisfies this type of condition, definitely that is called a homogeneous function. Homogeneous function. See, this is a homogeneous function of degree 3, isn't it? So now from this I am going to take x cube as a common term. If you take x cube as a common term, there will be 3. This is 3y by x plus 2y square by x square plus 4y cube by x cube. So whenever you take highest power as a common term x cube, then this entire terms becomes, this is a function in terms of y by x, y by x, y by x. So this is x cube into f of some other function g of y by x. If you take x cube as a common term, then the remaining function is in terms of y by x. Suppose if you take y cube as a common term from the same function. If we take y cube as a common term from the same function, then what will happen? Let us see. It is x cube by y cube plus 3x square by y square plus 3x by y plus 1. So then this is the function in terms of x by y. This is the function in terms of x by y whole cube, x by y whole square, x by y to the power of 1. So the x cube into g of y by x or y cube into g of x by y. So if the function is in terms of like this, say f of x comma y is equal to x cube into g of y by x or y cube into g of x by y, then that is also the homogeneous function. And that is also the homogeneous function. Now, let us see what is a homogeneous differential equation. See, if the differential equation is of the form dy by dx is equal to f of x comma y by g of x comma y. If the differential equation is of the form dy by dx is equal to f of x comma y by g of x comma y. Here the very important point is here f of x comma y and g of x comma y are both homogeneous functions. Both are homogeneous function of same degree. Very important. Here f of x comma y and g of x comma y are both homogeneous functions of same degree. Suppose if numerator is a homogeneous function of second degree and denominator is a homogeneous function of fourth degree, then it won't be a homogeneous differential equation. We can't solve it. We can't solve it. Okay, so let us see how the questions are look like. The question is like this, he has given, solve dy by dx is equal to xy by x square plus y square. Dy by dx is equal to xy by x square plus y square. Given that y of 1 is equal to 1. Given that y of 1 is equals to 1. Observe, in each and every question, this condition is compulsory. Right? So dy by dx is equal to xy by x square plus y square. So let us see. Check. So here the numerator is xy. So in that numerator only one term is there. So what is the order? I mean, what is the degree of that term? 2. Here in this term 2 variables are there. That means clearly numerator is a homogeneous function of degree 2. So in the denominator 2 terms are there. In each and every term 2 variables are there. X square 2 variables, y square 2 variables. That means denominator is also a homogeneous function of degree 2. Here both the numerator and denominators are homogeneous functions of degree 2. So this is a homogeneous differential equation. So let us see how to solve what is the process to solve a homogeneous differential equation. So whenever homogeneous differential equation is given, this is the process. First let us take the substitution. Put y is equal to Vx. Put y is equal to Vx. So why you take y equal to Vx, sir? So as I told in the concept, so every homogeneous differential equation can be expressed as x power n into f of y by x, g of y by x, or y power n into g of x by y. So in terms of x by y you can express, or in terms of y by x you can express. So generally, so we can express the given differential equation in terms of y by x. See, v equal to y by x. See, v equal to what is it? Y by x equal to v. So that means I am taking y by x as a substitution here. Why? Because this is a homogeneous differential equation. You can convert in terms of y by x or x by y. Generally, we are going to convert in terms of y by x. That's why we take y by x as a substitution. So y equal to vx. So here v is not a constant, v is a variable. So differentiate with respect to x. The derivative of y is dy by dx is equals to here. You have to apply product rule. So uv rule. So v into the derivative of x is 1. So v plus x into the derivative of v is dv by dx. So dy by dx is nothing but v plus x into dv by dx. Y is nothing but vx. So whenever we take the substitution y equal to vx, you have to replace dy by dx with this v plus x into dv by dx. So let us replace. First replace dy by dx, that is v plus x into dv by dx is equals to, after that replace every y. First replace y, x into y means vx, x into vx is nothing but vx square whole by x square plus y is nothing but vx, y square is nothing but v square x square. Here in the denominator x square is a common term. After taking x square, that x square and this x square gets cancels. So there is x into dv by dx is equals to, here what is the remaining term after taking x square as a cancel term? So v by 1 plus v square, right? And take this plus v to that side, minus v. Achha. So x into dv by dx is equal to, here take the LCM, 1 plus v square is the LCM. So what do you get in the numerator? V minus v cube. Here plus v minus v gets. Now observe, in this differential equation only two variables are there. Those are v and x. So now we can separate the variables. Now I can bring all the v terms to dv side and all the x terms to another side. So see, this is minus v cube by 1 plus v square, minus v cube by 1 plus v square. So take this minus v cube by 1 plus v square to that side. So then what will happen? So 1 plus v square by v cube, 1 plus v square by v cube dv is equal to, minus sign is already there, and take this x by dx to that side, it will become dx by x. It will become dx by x. So now bring both the terms to one side. So 1 plus v square by dv, so 1 plus v square by v cube dv plus dx by x, that should be equal to 0. Now the variables are separated. So now we can integrating on both sides. So to integrate this one, split it, 1 by v cube dv plus integral v square by v cube, it is 1 by v dv. It is 1 by v dv plus integral dx by x, that should be equal to 0. So now integrate each and every term separately. What is integration for 1 by v cube? So 1 by v cube can be written as v to the power of minus 3. What is integration for x to the power of n? The integration for x to the power of n is x to the power of n plus 1 by n plus 1. So the integration for v to the power of minus 3 is v to the power of minus 3 plus 1 by minus 3 plus 1. So v to the power of minus 2 by minus 2. So that can be written as minus 1 by 2v square. So the integration for 1 by v is log v. The integration for 1 by x is log x, is equal to c. Now replace v. So what is v? V means y by x. So minus 1 by 2 y square by x square. So that is minus x square by 2y square plus this is log of y by x plus that is log x is equal to, see, this is the solution of the differential equation, that is called a general solution. So he has given a condition, so y of 1 equal to 1, again y of x is equal to something, that means you have to substitute 1 in the place of x as well as y here. So put x equal to y equal to 1 here. If x equal to y equal to 1, this term becomes minus 1 by 2, minus 1 by 2. Here if x is equal to 1, y equal to 1, log of 1 by 1, it is log 1, 0. That is also log 1, 0. So c equal to minus 1 by 2. By substituting x is equal to y equal to 1, say y equal to 1, we got the constant value as c by 2. Just replace c by 2 equals c value is minus 1 by 2, we will get the answer. Right? This is the way to solve a homogeneous differential equation. Okay, we'll discuss one more example based on it. The next example is like this, based on homogeneous. X into dy by dx is equal to y into log y to the base c minus log x to the base c, log x to the base c plus 1, plus 1. And y of 1 is equal to, given that y of 1 equals to 2, then he is asking y of 2. If y of 1 equal to 2, then y of 2 equal to how much he is asking. So now this is the given differential equation, right? So the solution is like this. So dy by dx is equal to, take this x to that side, it is y by x times of. Now observe this term, that is log y base c minus log x to the base c. It is of the form log a minus log b. Log a minus log b is log of a by b. It is log of y by x plus 1, plus 1. So this is y by x and this is y by x. Now this is the function in terms of y by x. Now in terms of y by x, if the function is in terms of y by x, definitely you can take it as a homogeneous function. So now let us take the substitution, y by x equal to v. So put y equal to x. Put y equal to vx. So if y equal to vx, then automatically dy by dx is equal to v plus x into dv by dx. Just now we discussed it. Just replace these two values in this differential equation. Dy by dx means v plus x into dv by dx, isn't it? Is equal to y by x. Y by x is nothing but v. So v into, this is log v plus 1. Acha, right. So v plus x into dv by dx is equal to, just open the bracket on RHS. This is v log v plus v into 1 is v. Here plus v gets cancels. Now again, in this differential equation, only two variables, those are x and v. We can separate the variables here now. So bring v log v to this side and x dx to that side. So what will happen? This is dv by v log v is equal to dx by x. Now the variables are separated. Now it is ready to integrate. So integrating on both sides. Integrating on both sides. So now this is 1 by v log v. That can be written as, see, 1 by v whole by log v. Can I write like this? Is it 1 by v log v? Definitely. So 1 by v log v can be written as 1 by v by log v dy. So log v dv is equals to integral dx by x. Now why you wrote like that, sir? I'll explain. So here denominator is log v and the numerator is 1 by v. See, the denominator is log v and the numerator is 1 by v. So it is of the form integral f dash of x by f of x. Integral f dash of x by f of x. Integral f dash of x by f of x formula log of f of x. So here log v derivative is 1 by v. So the integration for this is log of log v. Log of log v is equals to integral dx by x is nothing but log x. Here I am going to write the integration constant as log c. You can write anytime, anywhere, anyway. So log of log v is equal to log x plus log c. Here the RHS is of the form log a plus log b. Log a plus log b formula log ab. So log v means y by x. V means y by x is equals to log cx. Right. So now we can remove the logarithm. So log of y by x is equal to log of y by x is equal to cx. Log of y by x equal to cx. This is the solution. Now initially is given that y of 1 equal to 2. Initially is given that y of 1 equal to 2 is y of x. Y of x. That means x is equal to 1 and y equal to 2. So put x is equal to 1. Put x is equal to 1 and y equal to 2. If x equal to 1 and y equal to 2, then what will happen? It is log 2 by 1. It is log 2 is equal to the value of c into the value of x. I mean x1 now. C into 1 is c. The value of c is log 2. So therefore, log of y by x is equal to c value log 2 it into x. So it is x log 2. X log. So log of y by x is equal to x log 2. And finally, what he is asking? Y of 2. That means what is the value of y when x equal to 2? This means what is the value of y when x equal to 2? So that means put x equal to 2 in this. Put x equal to 2. If x equal to 2, it means log of y by 2. Log of y by 2 is equal to 2 log 2. Right? Log of y by 2 is equal to 2 log 2. How do you write 2 log 2? Log 4. Acha. Log of y by 2 is equal to log 4. Right? Log of y by 2 is equal to log 4. That means y by 2 equal to 4. So therefore, y equal to 8. Y equal to 8. So when x equals to 2, the answer for y is 8. So what is the value of y of 2? 8. That's it. Okay. So this is the way to solve a homogeneous differential equation. Clear? Achha. And the next one, very, very important one, that is third one, linear differential equation. Linear differential equation. Frequently he is asking this method only, linear differential equation. He is asking the questions based on this linear differential equation frequently in JEE Mains. Listen carefully. A differential equation is of the form, dy by dx plus py is equal to q. A differential equation is of the form dy by dx plus py is equal to q, or a differential equation is of the form dx by dy plus px is equal to q, or a differential equation is of the form dz by d theta plus pz is equal to q. Yeah, there is a similarity in all those equations, P and Q, P and Q, P and Q. What are P and Q, sir? Very, very important. So here, this is the derivative of y, derivative with respect to x. Here, derivative with respect to x, here, derivative with respect to y, here, derivative with respect to theta. So here, the derivative with respect to x. So here, P and Q, if P and Q are the functions of x or constants, if P and Q are the functions of x only or constants, then this is called a linear differential equation. See, the derivative of with respect to x, what is the other variable? Y. So y must be present here. Y must be present there. So here, what are the variables? X and y. Here, the derivative with respect to y. So that means here P and Q are the functions of y only. Here P and Q are the functions of y only, or constants. What is the other variable? X. Here x must be present. Clear? Achha. Here what are the variables? Z and theta. Here the derivative with respect to theta. So that means here P and Q are the functions of theta only. Here P and Q are the functions of theta only. The other variable Z, it must be present there. So whenever a differential equation is like this, that is called a linear differential equation. Linear differential equation. Then what is the process to solve this differential equation? So whenever a given differential equation is of the form dy by dx plus py equal to q, that is called a linear differential equation. Whenever linear differential equation is given, first of all, we have to find out IF. IF. What is IF, sir? IF means integrating factor. See, IF. So what is the formula to find out IF, sir? E power integral p. E power integral p. See here, that is the derivative with respect to x, that means p and q are the functions of x. So e power integral p dx. IF means e power integral p dx. Here IF means e power integral p. E power integral p. Here p and q are the functions of y. So e power integral p dy. Here the IF is e power integral p. Here also the IF is e power integral p. But the variable of integration is very important. Here the variable of integration is x, y, because p and q are the functions of x. Here the variable of integration is y, because p and q are the functions of y. So now after finding IF, you have to find out the solution. Now the solution is, here p and q are the functions of y, sorry, here p and q are the functions of x, here p and q are the functions of x, therefore the solution starts with y. So the solution starts with y. Solution is y into IF is equals to integral q into IF. This is the solution. Y into IF is equal to integral q into IF. Here the variable of integration is important. Q into IF. Here q is the function of x and IF is also function of x. So here the variable of integration is x. So this is a solution for this linear differential equation. Y into IF is equal to integral q into IF dx. Now here the solution is, here p and q are the functions of y. So the solution starts with x. So solution is x into IF is equal to integral q into IF dy. X into IF is equal to q into IF dy. Clear? Right. This is called linear differential equation. This is a process. IF solution, IF solution. Right? Okay. Let us discuss some problems based on it. The question is like this. Y square minus x into dy by dx is equal to 1. Y square minus x into dy by dx is equal to 1. And y of 0 is equal to 1. Y of 0 equal to 1. Achha. Y of 0 equal to 1 is given. Okay. Achha. So the given differential equation like this, y square minus x into dy by dx is equals to 1. Here let us say, this is not a homogeneous differential equation. Here we can't separate the variables. We can't bring all the x terms to dx side and all the y terms to dy side. We can't bring. So let us see. And first of all, take this dy by dx to that side. Dx by dy is equal to y square minus x. So dx by dy equal to y square minus x. So dx by dy, take this minus x to this side, it is plus x is equal to y square, right? Achha. So forever convenient, this 1 into x, I am going to write 1 into x, can I write? 1 into x is 1 now, 1 into x is x now. Achha. So why you write like this, sir? Because it is of the form dx by dy plus p into x is equal to q. Clearly it is of the form dx by dy plus px is equals to q. Achha. Here q means y square, p means 1. That means here, so observe that here the derivative of x with respect to y, say derivative with respect to y. Derivative with respect to y, here x and y are the variables, here the derivative with respect to y. So here p and q are the functions of y only, or constants. Here what is p? 1, and what is q? Y square. So here p is equal to 1 and q is equals to y square. P is equal to 1 and q is equals to y square. So now to find out the solution of this linear differential equation, first of all you have to find out IF. So IF is equals to e power integral p dy, because p and q are the functions of y only. Achha, 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 achha. So it is e power integral p means 1 dy. Integral 1 dy is y. So therefore here IF is equals to e power y. IF is equal to e power y. Now solution. Here p and q are the functions of y. So what is the other variable? X. So the solution starts with x. So solution formula, x into IF is equals to integral q into IF. Here q and IF are the functions of y, so that you have to write the variable of integration there, y. So x into IF means e to the power of y is equals to, here IF, right? First IF is nothing but e power y, and after that y square. Q means y square dy. So the x into e to the power of y is equals to that e power y into y square. Actually for this we have to apply by parts, integration by parts we have to apply here, but it is not required. There is a shortcut process. Whenever e power y into a polynomial function, some e power x into a polynomial function is there, so you can find out the integration directly, that is e power y into, apply the shortcut, e power y into, what is a polynomial? Y square. Write the polynomial first. After that, right, minus, what is the derivative of y square? 2y. After that, plus, what is the derivative of 2y? 2. After that, right, minus. What is the derivative of 2? 0. Not plus. Suppose, for example, e power y into y cube is there. E power y into y cube is there. So, e power y into y cube minus 3y square plus 6y minus 6 x0. So, this is the way whenever e power x into a polynomial function. For the polynomial function only, you can apply the shortcut. Right. So, for e power x into sin x, sir, can I apply? No. No, because sin x is not a polynomial. So, this is the solution for this linear differential equation as given y of 0 equal to 1 to find out the value of c. So, that means y of x, and put x is equals to 0 and y equals to 1. If x equals to 0, LHS becomes 0. If y equal to 0, and x equals to 0, y equal to 1. Na? Achha. So, e to the power of 1, 1, this 1 minus 2 plus 2, minus 2 plus 2 gets cancels. So, e to the power of 1 is e plus c. So, the value of c is equal to minus c. The value of c here is minus c. So, replace the value of c here. That is the particular solution of this linear differential equation. Right. We will discuss one more question based on it. Clear. The next question is like this. dy by dx plus y tan x dy by dx plus y tan x is equal to 2x plus x square into tan x, isn't it? dy by dx plus y tan x is equal to 2x plus x square into tan x, and given that y of 0 equal to 1, given that y of 0 equal to 1 again. Achha. See, clearly it is of the form dy by dx plus p into y is equal to q, isn't it? So, here dy by dx, here the derivative with respect to x, that means p and q are the functions of x. Clearly, p is tan x and q is 2x plus x square tan x, both are functions of x now. What is p? Tan x. So, clearly it is a linear differential equation. So, first of all, find out IF. IF is formula e power integral p dx, because p and q are the functions of x. So, that is e power integral p means tan x dx. What is the integration for tan x? Log of secant x. So, IF is equals to e to the power of log of secant x. So, e power log of f of x is nothing but f of x. So, this is nothing but secant x. So, what is IF for this? Secant x. Now, write the solution. What is the formula to find out the solution for this linear differential equation? Yeah, the derivative with respect to x, and the other variable is y now. So, the solution starts with the other variable. So, y into IF is equals to integral q into IF dx. So, it is what is y? So, y means y. What is IF? IF means secant x is equal to, first write IF means secant x into what is q? Q means 2x plus x square tan x. Qx plus x square tan x dx. So, how do you integrate it? Secant x into 2x plus x square into tan x is, how do you integrate? It's very difficult, but it is very important process, very important. Let us see. Y into secant x is equals to, yeah, just open the bracket. Secant x into 2x plus x square into secant x tan x. Isn't it? Achha. So, y secant x is equals to integral of secant x into, can I write dx as derivative of x square? 2x. Here, can I write 2x as derivative of x square? Derivative of x square is 2x, right? Plus x square into secant x tan x is the derivative of secant x. It is derivative of secant x. So, now this term is of the form u into derivative of v plus v into derivative of u. U into derivative of v plus v into derivative of u. That is nothing but derivative of uv. So therefore y into secant x is equals to so this entire term can be written as derivative of uv. So uv means secant x into x square, secant x into x square. So integral of derivative or derivative of integral of f of x or integral of derivative of f of x is nothing but f of x. So y into secant x is equals to, this is x square into secant x plus integral of derivative of secant x into x square, integration derivative, both are inverse process to each other, they will get cancelled. Y secant x is equal to x square into secant x plus c. So here y of 0 equal to 1 is given. That means again you have to write 0 in the place of x and 1 in the place of y. So put x is equal to 0 and y equal to 1, so that you will get the value of integration constant. So y1 into secant 0 1, 1 into 1 is 1, x 0, this term becomes 0, so the value of c equal to 1. Just replace the value of c here, you will get your answer. Okay, so we will get one more question based on linear differential equation. The question is like this, that x square plus 1 whole square into dy by dx, x square plus 1 whole square into dy by dx plus 2x into x square plus 1 into y is equal to 1, such that y of 0 is equals to 0, if square root of a into y of 1 is equal to pi by 32, then a is equals to, square root of a into y of 1 equal to pi by 32, then a is equals to 1 is asking. So this is the question, x square plus 1 into dy by dx plus 2x into x square plus 1 into y is equals to 1. So to convert the given differential equation into the form linear differential equation, first of all I am going to divide the entire differential equation with x square plus 1 whole square. So let us divide. So dy by dx is equals to 2x into x square plus 1 by x square plus 1 whole square. So this x square plus 1 cancels in x square plus 1 whole square one time. So dy by dx plus 2x by x square plus 1 into y is equal to 1 by x square plus 1 whole square. 1 by x square plus 1 whole square. So now clearly it is of the form again dy by dx plus p into y. dy by dx plus p into y is equals to q. So this is of the form dy by dx plus p into y is equals to q. So clearly it is a linear differential equation. Here p means 2x by x square plus 1 and q means 1 by x square plus 1 whole square. Both are the functions of x and here the derivative with respect to x. So therefore, so find out if. if is equal to e power integral p dx, that is e power integral p means 2x by x square plus 1 dx. 2x by x square plus 1 dx. Just observe, what is the derivative of x square plus 1? 2x. The derivative of x square plus 1 is 2x. The derivative of denominator presents in the numerator. So it is of the form f dash of x by f of x. Integral f dash of x by f of x is log of f of x. So if is equals to e power log of x square plus 1. E power log of x square plus 1. As I told, e power log of f of x is f of x. So e power log of x square plus 1 is x square plus 1. Here the if is equal to x square plus 1. Now the solution. Here the derivative with respect to x and the other variable is y. So the solution starts with other variable y into if is equal to integral q into if dx. So y into if is nothing but x square plus 1 is equals to, here q means 1 by x square plus 1 whole square, 1 by x square plus 1 whole square into if means x square plus 1 dx. This x square plus 1 cancel one time. What is the remaining term? Integral 1 by x square plus 1 time. Integral 1 by 1 plus x square, tan inverse x. So finally you got the solution as y into x square plus 1 is equal to the integration for 1 by 1 plus x square is tan inverse x. So tan inverse x plus c. tan inverse x plus c. That is the general solution. So as given y of 0 equal to 0, y of 0 equals to 0. So that means put x equal to y equal to 0. If y equal to 0, RHS becomes LHS becomes 0. If x equal to 0, tan inverse 0, 0. So that c equals to 0. So therefore, y into x square plus 1 is equal to tan inverse x. So therefore, y is equal to tan inverse x by x square plus 1. Y equal to tan inverse x by x square plus 1. Right. So now he has given another condition, root a into y of 1. Y of 1. Y of 1 means when x equal to 1, the value of y. Y of 1 means when x equal to 1, the value of y. So put x equal to 1 here. Put x equal to 1. That implies y of 1. Y of 1 is equal to, if x equal to 1, it is tan inverse 1, it is pi by 4, by 1 plus 1 is 2, pi by 4 by 2, it is pi by 8. So the value of y of 1 is pi by 8, the value of y of 1 is pi by 8, so just substitute y of 1 here. So therefore, root a into the value of y of 1 is pi by 8 is equal to pi by 32. Here pi gets cancels, 8 cancels in 32 4 times. So root a is equal to 1 by 4. If root a is equals to 1 by 4, then a equal to 1 by 16. 1 by 16. So this type of models only he is asking JEE Main. So if you watch this video properly, if you watch this video completely, definitely you can able to answer the question from differential equation in JEE Mains. Okay. So if you like this video, please share, comment, and don't forget to subscribe. Okay. Right. Thank you. We'll meet in the next video. Bye bye.